Okay, now I will proceed to the procedure for the experiment. Okay, before that before I proceed to all the steps, I would like to introduce you all the wires. We have three types of wires and two types of wire connector. Okay, I will name them as type A, type C, and type B. Okay, type A look like this, type B look like this, and type C look like this. And type A and type B both are the pin type connector. Okay, the pin one. And the type C connector, the clip one. Okay, clip one. Type A connector are prioritized for multi-stage transformer. For multi-stage transformer, you can only use type A of the wire. Okay, but if you have extra, you can use it on other instrument as well. No problem. That means that each group must have at least two type A wire because they are required to be connected to the multi-stage transformer. Okay, but let's say if you have four, then you have to reserve two for the multi-stage transformer. The other two you can use on other instrument doesn't matter. Okay, then the type B. The type B connector are suitable for the Teratron base and can be used for other if you got extra. Okay, for Teratron base, you can only use this pin type of the connector. Okay, you cannot use the clip type of the connector and then just simply put it in the Teratron. Okay, for type T, type C wires, it cannot be used for multi-stage transformer and Teratron. Then for the rest, okay. All right, so I just make it simple. For multi-stage transformer, you can only use type A. Okay, multi-stage transformer, you can only use type A. For Teratron, you can use type A and type B. Okay, but of course, you have you have extra, you can use on other instrument, doesn't matter. Okay, so please bear in mind, if you use the wrong wire type, I will deduct 6 points. Okay, because this is important because it shows that you don't understand why you don't understand that how the good contact of the wire is very important in doing this experiment. Okay, how to do the wire connection? We have three type of wires and two type of the connector, right? So type A is a pin type. Pin type. You just when you see the hole, you just plug the pin inside the hole. That's all. Okay. And type A connector very suitable for the multi transformer and Teratron. Of course, you can use it on other instruments like ammeter, voltmeter, resistor, battery, and power supply as well. If you have extra, okay, doesn't matter. And then for Type C connector, the clip one, this is how you clip it. Okay, you can see that this is the voltmeter, then simply just clip it, doesn't matter. Okay, the clip it. Of course, this voltmeter you can also use the Type B one, the pin one, just put it into this hole. Okay, so the Type B, you can see that you can put it into this hole, or you can also use the Type C wire to just clip it for voltmeter, resistor, power supply. Yeah, all this for ammeter, voltmeter, resistor, power supply. You can use either Type B, you just the pin type connector just to put it in, or you can use a clip type just to clip it. Okay. Okay, procedure. This is the first step. For the first step, you need to check all the wires to make sure they function perfectly. Because wire is very fragile. Okay, sometimes when the student remove the wire, it has break the wire, but without a notice. So when the wire is broken, then when you do the connection, you will not get the result. Okay, so you need to check all the wire. So these are three instruments that you need. First, you need the voltmeter. Secondly, you need the battery or power supply. And third, you need the wire. Okay, so if you use a power battery, then it's okay. But if you use a power supply, make sure the voltage is lower than 3 volt. Okay, if you want to use a power supply. How to do the connection? Very simple. Let's say this is a battery or this is a power supply. The positive terminal, okay, your negative terminal you connect to voltmeter. Voltmeter, then I think you should connect to 10 volt. This one. And then this 10 volt connect to battery, negative terminal. Then positive terminal, you just connect to another wire. Okay, another wire. Then this positive terminal of the battery, we connect to another wire. Okay, then you set up something like this. Then you just push this wire, just link it to this one, and this wire link it to this one. Then you test and see whether they got the voltage or not. Then after you're done, you just use the second wire, put it here. You just see whether they got the reading or not. Okay, so after you do this connection, this is one wire, this is another wire, right? So just put the first wire here, see whether you got connection or not. If got connection, that means that this wire works. Okay, then now you put the second wire and remove the first wire, put the second wire and test again and see whether they got the voltage or not. Yes, then you just test it and test all the wire. Right. Okay, so you can use battery or power supply. If you use power supply, make sure the voltage is not high. Okay, then secondly, the second step, you need to make sure all the settings are correct. For the resistor, first and third experiment, you should do 1000 ohm. Second experiment, you should do 100 ohm. Okay, for the reading, you can refer to your lab manual. Okay, the apparatus that is mentioned there. For multi-stage transformer, for experiment 1 and 2, you should use 6 volt AC alternating current. Experiment 3, you should use 4 volt. Okay. Then for the diatron, for experiment 1 and 3, we use the xenon, the smaller bulb. And then for experiment 2, we use argon, the bigger bulb. Okay, don't use the wrong one. And then whether you should choose picoammeter or milliammeter. For experiment 1 and 3, we use picoammeter. Experiment 2, we use the milliammeter. Okay, so for picoammeter, after you turn it on, you show something like this, right? 0.0000000 microampere, and this one is zero correction. So for picoammeter, remember to press the jack CHK 0 check and jack 0R jack correction button a few times until this one disappear. Okay, then you can start to use the picoammeter. Okay, the step 3, you are required to connect the circuit as in figure 1 to 3 in the experiment, respectively. And then I have actually put the summary on the table. You can read it. Okay, so I have also redrawn the circuit for experiment 1, 2, and 3. All right. So for this briefing, online briefing, I will only show you experiment 1 because once you know how to do experiment 1, 2, and 3 are just similar. Okay, are just the same. So this is the circuit for experiment 1. It's actually quite simple. This is a power supply. Okay, you see the positive here. Power supply positive. Let's say I'm using this, so I connect one wire to this positive. One end connect to this one. The other end I connect to resistor. Okay, the other end I connect to this point. Okay, then resistor connect to voltmeter. So this is from connect to power supply in, then this one I connect to voltmeter. Okay, I connect to positive of the voltmeter, I connect to this point. positive of the voltmeter. Okay, then the positive connect of the thermometer I connect to thermotron G. Then negative of the voltmeter, let's say 30, I connect it to negative of the power supply, the black color one. And then the other one, I connect it to K. Okay. So just now I say that positive connect to G, so I just connect to G, and I use this type of the pin type. Okay, pin type wire, I push in G, and then negative, I connect to K. So let's say you see that the voltmeter positive have to connect to two connection, right? Negative also have to connect to two wire. So how to connect two wire? You can do it this way. So one wire plug in, the second wire is clip. Okay, if you have three wire, then you just use the clip to clip here. As long as they got contact at one point, then it's fine. Okay, if there are three wire like experiment 3. So I have power supply connect to resistor, then resistor connect to voltmeter connect to G, done. And then voltmeter negative connect to power supply negative, the black color one. Then negative connect to K, done. Okay. So the other K, this K connect to positive of the battery cell, so connect to this point. Okay. Then negative of the drive cell, this wire connect to pico ammeter. So on the back side of the pico ammeter, you can see they got the CAT here, and then I have connect the the two connector here, red color and black color. So the negative of the battery is wire. You have to clip it using the wire and connect it to black color. Okay, this side black color. Then the pico ammeter positive red color one. You use one wire connect to this red color, and then the other end connect to this A. Okay. Then we'll complete this side. And the last part is the H. H. These two H have to be connected to the multi-stage transformer, 6-volt alternative current. So we have to use the type A wire. Bear in mind, you can only use type A wire. One end you connect to this AC, the other end you connect to this H. Then now you use the second wire, connect to this AC, and then connect to this H. Okay. Then you have completed the setup. So same thing apply to experiment 2 and experiment 3. Okay, so power supply connect to resistor connect to milliammeter positive, and milliammeter negative connect to V positive connect to A, V positive connect to G. V negative connect to power supply, V negative connect to K. Then we have 2K right here. Then this 1K, the other K, you just leave it empty. Okay, doesn't matter. Then the 2H, you should connect it to the multi-stage transformer. Okay, for experiment 3, this one should be forward. Okay, one correction forward. So same lah. Okay, now I'll proceed to the data collection. There are some correction to the lab manual. For experiment 1, the procedure step A, I want to change it from 0 to 14 to 0 to 16. For experiment 2, the step 6, I want to change it from 0 to 18 to 0 to 20 or 22. Doesn't matter. Experiment 3, step 8, I want to change it from 0 to 7 to 0 to 11. Okay, please change it right now in the black manual. Okay, for data collection. So for each experiment, there will be 2 tables and 1 graph. 2 tables and 1 graph for each experiment. Experiment 1, 2 tables, 1 graph. Experiment 2, 2 tables, 1 graph. Experiment 3, 2 tables, 1 graph. So in total, there will be 6 tables and 3 graphs for all 3 experiments. Okay. So for the first table, you should prepare something like this. I got the power supply. Reading 0, 1, 2, 3, 4, 5, 6 up to 16 for the first experiment, up to 16. Then the voltmeter reading, ammeter reading. Okay, so the first time, second time, third time, then average. So for experiment 1, you have to increase the voltmeter from 0 to 16, 0, 1, 2, 3, 4 up to 16 in the voltage of 1 volt per step. So 1, 2, 3, 4 up to 16. For experiment 2, it's from 0 to 20 or 22. Okay, but then now you increase the voltage in the step of 2 volt. So that means you start from 0, then followed by 2, 4, 6, 8, then up to 20 or 22. Okay, for experiment 3, you have to collect the data from 0 to 11 in the voltage. It increase the voltage in the step of 1 volt. So again, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so you have to construct this table on the A4 paper or on the full scrap paper. So how to do the data collection? Okay, so let's say for the example, you want to take the voltage for 2 volt. Okay, 2 volt, 2 volt. How to take the 2 volt? So just turn this button or this button. Just turn it until you see here 2.0, 2 volt. Okay, after you see that this reading 2.0, then you just record down the reading of voltmeter as well as the milliammeter or picoammeter. Okay. So you just turn it to 2.0 volt, then you record the reading of the voltmeter and ammeter. Okay, either milliammeter or picoammeter, depends on which experiment that you are doing. Alright, so just record it down. So here you put 2. Here you put 2 volt. Then let's say this is S1. Then the ammeter is Y1. So now you turn this button again to any random value. Let's say for 8 volt, 6 volt, 7 volt, turn it to any value. And then return it to 2.0 again. Then you record it for the second time. So now you got S2, Y2. Okay, then again, repeat the process, turn it to, let's say, any value, turn it, let's say, up to 4.0, and then go back to 2.0, turn to random value and return to 2 volt, and record for the third time. So now you have F3, Y3. Then you calculate the average. Okay, then now you proceed to power supply 3 volt. So you turn it to 3.0 and then repeat the process. All right. So whenever you found that this point, the light is on, red color. You see the light is on, C dot C, the light is on. Then you have to turn these two buttons. Okay. You turn this button, current, to increase the current. You see, I got two buttons, right? For this type of the power supply, got two buttons. Current got two buttons, voltage got two buttons. Left button one, this one means the smaller scale, and this button means the larger scale. What I mean means that, okay, like voltage, this button when you turn it, maybe increase by 1 volt or 0.1 volt, but this one maybe by 0.001 volt only. Okay, this when you turn it, it got a smaller scale. This one got a larger scale. Okay, what if when you turn on the power supply, but the reading doesn't start from 0.00? Okay, I mean the voltmeter it doesn't start from 0.00. Then you just treat it as the zero error lah, because some old power supply cannot reach zero, but it's okay. Start from whatever value is it lah. Okay, so now we have three variables. Okay, we have power supply, we have voltmeter, we have ammeter. Okay, so we have three variables. When you plot the power supply versus voltmeter, you get the graph like this. When you plot the graph of power supply versus ammeter, you get the graph like this. Okay, why? Okay, the objective for the first experiment is to determine the first ionization potential of xenon. Okay, so at first, the xenon are neutral. Then after the ionization process, it becomes ion. Okay, ion, charged particle. Charged particle. So the xenon atom before the ionization cannot flow in the circuit, but when it becomes charged particle, it can flow in the circuit, and it has been reflected in this graph. You can see that when at first you cannot detect any current. Current means the rate of flow of charge inside the circuit. When it's almost zero, that means that there's no charge flowing in the circuit. But when it reaches certain power supply voltage, the current slowly increase. It indicates that now they got charge flowing inside the circuit. Where the charge come from? The charge actually come from the ionization of the xenon xenon atom to xenon ion. Because at first it was the atom cannot, for this region, atom cannot flow inside the circuit, so you cannot detect the current. But when the xenon has been ionized into charged particle like ion, then now you can see that you get the increment of the current. Now you can detect the current, and this current, this part is actually contributed by the charged xenon ion. Okay, so this is what this graph can tell us. So this graph, you can see that, okay, when you increase the power supply, the voltage inside the circuit also increase. Until it reach some point, it dropped. Why it dropped? Because the voltage has been used to ionize the xenon atom into xenon ion. Okay, that's the reason why the voltage dropped. Okay, so what is our first objective? The first objective is we want to determine what is the voltage required to convert the atom to charged particle. So of course, from this point of view, we can know that it's somewhere near here lah. These 2 points lah. Right. Therefore, we want to combine these 2 graphs into one. So we use the picometer or millimeter versus the voltmeter reading. So when you combine these 2 graphs, you will get something like this for the first experiment. So we know that, okay, this is the turning point, and this turning point gives us the hint that what is the first ionization potential. So it's somewhere near this point lah. So this voltage is the first ionization potential required to ionize the xenon atom to xenon ion. So we have achieved our first experiment after preparing the graph. Okay. So for the first experiment, you just need to draw this graph, which you use the ammeter versus voltmeter. Okay, this one, ammeter versus voltmeter. Then you got this graph. Okay, after that means that you have the first table, and then you have the first graph. This graph you have to plug into the graph paper lah. Then we know that this is where we can get our answer, right? The turning point. So we would say that this is our region of interest. For this region of interest, you can design your own range. Let's say I want to get from this point to this point, and I use the 10 to 13. It depends on the graph. Okay, you can choose your own range. It can be 11 to 14, 9 to 13, whatever. Depends on the graph. That you can pick your own range. Doesn't matter. So I know that this is my region of interest. So as a scientist, I want to get a more accurate data. So I prepare the second table. So I know that you see here. For the first experiment, when you use an I versus P, you will get the graph shape like this. For the second experiment, you will get the graph shape like this. Third experiment, you get the graph shape like this. Okay, experiment 1, experiment 2, experiment 3. So you are required to plot the current versus the voltage in the graph paper. So, and we know that you have to determine the range of the region of interest. Okay, for the first experiment, we know that this is where we can get our answer for this region is where we can get the answer for our objective. For second experiment, this turning point. For third experiment, this turning point. Okay, so for this turning point, I have to determine my region of interest. So I will take, let's say, like 11 to 13, like what I told you just now. You can choose any other region that suit your own graph. Okay, for first experiment, 11, 13. So from 11 to 13, I prepare the second graph. Okay, second graph. I'll start from 11 and then finish at 13. Previously, I used 1 volt per step, right? But now because I want to get more accurate data, so I use the smaller scale, like 0.5. So now I use the first reading 11, the second reading 11.5, followed by 12, and followed by 12.5. Okay. Or you can even use the smaller scaler like 11, 11.25, 11.5, and so on and so on. Okay. So experiment 1, increase the voltage in the step of 0.5 volt. And then what is the region? It should be depends on the graph. So the same thing is just for 11. You just turn the voltage to 11 and then record down the voltmeter for the first time, ammeter reading for the first time, second time, third time. Can you get average? Okay. Once you got this additional reading, you go back to your graph and then you just go back to your graph and then just plot the additional reading on the previous graph and then you fix the graph. Okay, you just fix the graph and make it better. So in short, you will have 2 tables and 1 graph. Right. Okay, why do we need to do the additional reading. Okay, the region is simple. Okay, let's say this is the data that without the region of interest, look like this. You just first reading, second reading, third reading, fourth reading, fifth, sixth, seventh. Okay, you just plot it. So you look like this. Then you may link all this together. Right. So this is what you do. But different students may have different perspective. So the first student said, oh, this is my graph. The second student said, no, I prefer the graph like this. The third student said, no, I think this one is better. So now I have 3 turning points. Which turning point is correct? We cannot tell. Okay, even the lecturer also cannot tell. So how to resolve this issue? If you pick this as a region of interest and you get extra point. If I got extra point here, then now I can tell that, okay, this is the correct graph. You got what I mean? So the first table give you this point. Then you need to determine that this is the region. Then second table give you additional point here. Then you'll get the perfect graph. Okay, so different students can have different graph. If you plot the graph without the region of interest, to solve it, you can get the second table to get the reading for the region of interest. Then when you have region of interest, then you have more spots here, then you know that, okay, which one is correct.